So, hi, I'm Bryant. I'm a rising senior at Scotts High School, and my main project was the RC Hovercraft, which uses fans to hover and move around. And I will give a quick demo of it and try to drive it down the aisle. We'll see if it works. So, Hovercraft consists of two main parts, the main body and the electronics. The main body is made out of Dempron foam, and the skirt I have made out of nylon tent fabric. For the electronics, I have two batteries, which I will now unplug. They power the circuit, and I also have two fans in my main movement systems. I have one fan embedded in the base. This provides the lift for the hovercraft, and the fan on the back provides the thrust, which is a lot easier when it's off the ground, due to less friction. I also have two electronic speed controllers, or ESCs. These take power from the batteries and signal from the receivers. It then uses the signal to determine how much power to let through the motors. This then determines how fast the motors spin. I also have a servo back here. This servo rotates the thrust fan, and that rotation determines how the hovercraft turns. The servo is powered and controlled directly by the receiver, unlike my DC motors, because they have a different powering system. The receiver gets its signals from the transmitter via radio waves. It then converts these into electronic signals using a preset standard key that is already encoded in the receiver. When designing this project, I learned how to use CAD tools. These greatly sped up the process of designing the hovercraft. And then, although I did have to cut out each Dempron part by hand, I also had to figure out weight distribution. If the weight isn't distributed evenly, then the hovercraft will not fly straight. Because of this, I placed batteries on either side in the same positions at the front of the hovercraft. This keeps the weight distributed evenly side to side, so I don't end up with problems going diagonally. I also had to figure out how to attach this thrust fan to the servo. Because the fan is round and the servo is flat, I had a small gap in there. Because of this, super glue wouldn't work, so I used hot glue. It filled the space and is strong, unlike taper zip ties, which were my first two ideas. Coming into BlueStamp, I mainly had knowledge on the software side of engineering. However, after this experience, I've learned a lot more on the manufacturing and design processes. I've also learned how to create solid, safe, and secure electrical connections. I'm now much more interested in the mechanical engineering side of things, and will be focusing on projects with some aspects of mechanical engineering. My next project will be to create a top for the hovercraft so that it looks better. Thank you.
Your hovercraft, how durable will it be in much more like rough terrain, let's say outside or something?
The fan in the base sticks out a bit at the bottom, so it's possible that that could get scuffed up if I went on rough terrain. It's also possible that it would grow off the steering of the hovercraft if it hit any rocks. So probably not super well.
And along with that, like the wind, how does that play into the factor of the hovercraft? Like if there's wind outside or something?
It would definitely apply force and make the hovercraft it would definitely cause the hovercraft to drift a bit, because the idea of the hovercraft is to have lower friction so you can move by a fan. Any other questions?
How long did it actually take you to learn how to control it?
A few hours probably. It took a while. It's still difficult to control because it often doesn't like to, like the fan in the back is also the thrust, so if I want to turn, I also have to go faster. If I had like side propellers or something to steer it, then it would be a lot easier.
How come you didn't choose to use a rudder to lead around
Since I don't have a roof, it's a lot harder to attach the thrust fan on its own. So that I didn't have to make a roof, I just attached it to the servo directly.